You knew it was coming. And that is now the need for us to do multiple rotations just to get one node into the right spot. Now, the good news is that, yes, it is using recursion. The code we give you, or it's already been done or something like that, you're not going to do this by scratch unless it's some, a project. But the recursion part of this is just something for you to keep in back your mind. I'm not going to be going over any code on this. But think of it every time as you do something that when you're not done yet, it's probably using recursion. And again, it's recursion because we're using a recursive structure. And each time we got to double check, hey, what's my current situation? That's recursion because we're still deep in the tree. We're not done yet. We're not all the way to the top. All right, I'm not done yet. Let me look around at my surroundings. That's exactly what you're going to be doing for this algorithm. So recursive zigzags and zig-zigs, you're still always going to start from the bottom. So we have a tree here. We add 15 into the location of the tree. That's our overall insertion phase or placement phase. And now we got to do the ID phase, the rotation identification phase. So we want to move 15 all the way to the top. But right now, currently, we only have a rotation that's going to move us 2 levels. And that's okay. We also know that's going to be a zigzag because of literally the zig and the zag that you see here. So we're going to use that zigzag to at least move X up 1 spot, and that's going to look like this. So here we've moved X 15, there's 10, so notice it's a binary search tree, but we're not done yet. We still have to do one more thing with 15, so we go ahead and make that an X, and here's the recursion. I reset that to X. I look at what the other nodes that I have here and what I need for my rotation, and that's going to be, as you can probably figure out here, it's only 1 level, so that's going to be a zig to the left. And if I follow the zig to the left overall rotation, that's what's going to end up happening for our tree. Now notice again, we still got to double check. Is 15 at the top? Yes. Is this a binary search tree? Yes. Is it still using the same placement, ID the rotation, and rotation phases? Yes. It's still doing all 3. We just had to do it multiple times just to get that 15 in the right spot for that particular placement of one number, which was 15.